Good morning, Logan. It's Monday, March 23rd, and time for another lesson in Algebra 1. All right, so some of you have been asking about how we should take care of the notes. This is what you need to do is if you'd like to take notes, you may. If you don't want to, you don't need to, but I do need you to be working on the assignments. You'll notice that this video is slightly different. This one actually mimics the worksheet that is online. So if you wanted to, you could print it out and follow along and then do the problems on your own at the very end of it. So we're going to jump straight into it. We're going to be solving quadratic equations using square roots. This is a little bit different from section 9.1. In this section, if you wanted to write that down, this is section 9.2. In section 9.1, we graphed them and then found the solutions based off the graph. What we're going to do now is we're going to use an algebraic approach. To do this, we have 4 steps. Step number one right here, I need you guys to isolate the square component. Okay, so if you don't know what the square component is, it's the thing that has to the power of 2. So if you take a look at question A, that right there, that's the square component. We need to get that by itself. Over here, that's the square component. We need to get it by itself. And over here, you'll notice the square is actually to the entire x minus 3. We need to get that by itself. And over here, we need to get this 2x plus 1 to the power of 2, that by itself. So we're going to be isolating each of those square components, and then we're going to move on to the second step. Now, the second step is to take the square root of both sides of the equation. That is to eliminate the square. And then step number 3 is it's a kind of a weird one, so I'll explain it when we take a look at question A. Is to remember to include both positive and negatives versions of the square root. And then finally, fourth step is to isolate the variable if you need to. So if the variable is not isolated after you square root both sides, you're going to want to isolate it. All right, so let's jump into it. Question problem A. We're going to divide both sides by -3 because we're isolating the -3x squared. We're isolating the x squared component. All right, so we're going to divide, those cancel out, and we get x to the power of 2 is equal to 25. So now what we want to do is we want to isolate the square component, which is just happened right there. And now we need to take the square root of both sides of the equation. So we're going to square root the left side of the equation, and we're going to square root the right side. The reason we square root the left side is so that that square root can cancel out with the square and leaving us just x. So now we have just x. But if you take the square root of 25, I know most of you will say that the square root of 25 is 5. But here's the thing. 5 is not the only number that you can multiply by itself to get 25. There's actually a second answer. The second answer is -5. Because if you multiply a -5 times a -5, you still get a positive 25. And that's what I'm talking about in step 3 of solving square roots, is that you need both positive and negative versions of that square root. Since the variable has already been isolated, you don't have to do anything else, so there is no step 4, and you can move on to the next problem. All right, problem B. In problem B, what you want to do is you want to add the 15 to both sides so that we can isolate the x squared. So we're adding 15 to both sides, and the result is 4x to the power of 2 is equal to -40. So now we're going to try to get rid of that 4 by dividing both sides of the equation by 4. So we divide the left by 4 and the right by 4. The result is going to be x to the power of 2 is equal to -10. At this stage, the last step is to get rid of the square by square rooting both sides of the problem. So we square root the left side and the right side. The square and the square root cancel, and the result is x equals the square root of, that's not good, a negative number. So anytime you guys see that in Algebra 1 and going on through Algebra 2, what you want to do is if you have a negative inside of a square root like that, just write down that there are no real solutions. No real solutions. When you move on to Algebra 2, we'll talk about what it means to have these things that some of you might call fake solutions. We actually call them imaginary or complex. But anytime you guys get this in this class, just write down, hey, there's no real solutions. The solutions are imaginary. So our answer for question B, no real solutions. All right, with that said, we're going to move on to question C. Now, question C is a little weird because you have to isolate the square component. Now, in this problem, it's not the variable that's being squared, but it's actually an entire set, an expression, x minus 3. So we want to get the x minus 3 to the power of 2 by itself. We're going to start by dividing both sides by 4. So we're going to divide the left side and the right side by 4. Now, this isn't a nice thing because on the right side, 9 can't be divided by 4. The good news is all I need you to do is just leave it as a fraction. So we're going to write down x minus 3 to the power of 2 is equal to 9/4, just like that. Moving on, the next step. Since the square component is isolated, we're now going to square root both sides to get rid of that little 2. So we're going to get rid of the power of 2 by square rooting both sides of the problem. Step 3 says when you square root both sides, you need to remember to keep a positive and negative versions of those square roots. So on the right side, you're no longer going to have 9/4. You're going to have the square root of 9/4, which is equal to 3/2. But because step 3 says you need to remember both versions, we're going to write x minus 3 is equal to 3/2, and x minus 3 equals -3/2. Moving on to the last step, we need to isolate the variable. So you'll notice that the variable is not by itself yet. So we want to get it by itself by adding 3 to both sides of the equation. So we add 3 to both sides. Now on this one here, you're going to want to find a common denominator. And when you add 3 over 2 to 3, you end up getting 9 over 2. And on this one over here, you're going to add 3 to both sides of the equation. And when you do that, you're going to get x is equal to, when you take 3 halves away from 3, you get 3 over 2. Now, if you don't understand how I did this problem right here, the last step with the fractions, it was just finding a common denominator and then subtracting or adding based upon that common denominator. All right, moving on to the last problem, question D. First step, isolate the square component. The square component is already by itself. So first step is done. Step number 2, we're going to take the square root of both sides of the problem. So we're going to square root the left side and we're going to square root the right side. Now, remember, we need to have both positive and negative versions of that number. So we're going to say 2x plus 1 is equal, and here's the thing, I don't know what the square root of 35 is. I don't have any nice answer. When that happens, you just write down square root of 35. So if it's not one of your perfect squares that we wrote down at the beginning of chapter, I think 7 it was, then you can just write square root of 35. But remember, there are 2 answers. There's going to be 2x plus 1 equals root 35, and 2x plus 1 equals negative square root of 35. All right, so from this stage, what you're going to want to do is you're going to isolate your variable. So now that you square root both sides, the variable needs to be by itself. So I'm going to subtract the 1 from both sides. Fortunately, and I say fortunately because there's no math that needs to be done, is I can't actually subtract a square root number and a non-square root number. So we're just going to write 2x equals negative 1 plus the square root of 35. Next, we're going to get rid of the 2 by dividing both sides by 2. And since I can't divide by 2, I'm just going to write down my answer. My answer is x equals negative 1 plus the square root of 35 over 2. Now remember, that's only one of my answers. I still got to solve the second equation, which is over here. So I'm going to subtract 1 from both sides. And the result, that's a 1, sorry. The result is going to be 2x is equal to negative 1 minus the square root of 35. And then I'm going to divide both sides by 2. And this gives me my second answer, which is going to be negative 1 minus the square root of 35 over 2. All right, so these 4 problems should take you through the whole assignment. Please work on the 8 problems that are for homework. If you have any questions, please call, don't call. You can either text me or you can send me an email or you can hit me up on Google Classroom. I'm probably going to be more responsive if you hit me up on Google Classroom because that way a lot of your classmates can see the question and I can respond to help everyone out. All right, hope to see you guys soon.